Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look at a library for array functions. In this series of videos, I'll be covering the creation and use of libraries. So you might ask, why use libraries? Why not just write code whenever you need it? Well, if you're writing a lot of applications, having common libraries that contain functionality that you use often will save you time, both coding and testing. It will also make your code more readable and therefore maintainable, which is always a good thing. Today we're going to be adding a new library to our collection of code libraries. We're going to create a new PB Array Functions library. We already have one PB Sorting library, which specifically handles sorting arrays. And within our PB File Handling Routines library, we have a function which does an array dump. It takes a single dimension array and saves it to a file. We're going to expand on that concept in our new library. We're going to start with a plain text file. This text file contains 4 columns of data and 3 rows of data plus a header line. Our 4 columns are forename, surname, account and balance. And as you can see, this is a pipe delimited file. Although we're loading this from file, this could be coming from anywhere in your system. It could be coming from a database, it could be coming from another computer. What we will do first of all is to load this file into an array. So within our program, we'll create a new function whose job it is to do the processing. We'll create a new function called load a one-dimensional file. This will take a single parameter, which is the path to our 1D file we saw a moment ago. Our first task is to load the file into an array. There's a pre-built function in the File Handling Routines library which will do that quite nicely. The read the file into an array will return either a true or a false. True if we have successfully loaded the file into the array, and false if we have not. So we can handle this within the code and put messages out to our log. The new function in our new library that we're going to use is going to be called ArraySave1D. The task of this new function will be to take our array and output it to a file, but in outputting it to the file, it will amend the delimiter. So in order to do this, we will need 3 variables. strFilename, which will contain the path and the name of the file. strExistingDelimiter, which is a pipe character in the file and the array at the moment. And the delimiter we wish to use instead, which in this case is going to be a comma. We're going to turn it into a CSV file. And we will pass those 3 parameters, plus the name of the array that currently holds the data, to our new function. And like our other functions, it will return either true or false. If it returns true, it has successfully managed to save the array with the changes to the file. If it returns false, it has not. So we'll put appropriate messages out to our file. So before we have a look at the ArraySave1D function to see what it does, let's try running the program now and seeing what we get. In our folder, we have 1dfile.txt, which, as you'll remember, has 4 lines, 1 header and 3 data lines, and all the columns are pipe delimited. So if we try running our application now, we'll see on our log we certainly get the message to say that we managed to load the 1D file and we've managed to save it as well. If we have a look in the folder, we'll see there is now a 1dfile.csv. If we open that up, we'll see that the file is now changed from a pipe delimited file to a comma delimited file. And each of the fields are enclosed in double quotes. Therefore, if you have any data fields which have embedded commas, this would handle them quite nicely. So we have successfully taken a pipe delimited file and turned it into a CSV file. So let's have a look at the code of that function to see how it works. And here is the new function, ArraySave1D. It takes the 4 parameters we saw earlier, the name and path to the file we wish to save, the by reference pointer to the array containing the data, the string which holds the existing delimiter, and the string which contains the new delimiter. The function will first open a file for output, and for each row in the array, from the lower bounding to the upper bounding, it will read the data into a variable. If the new delimiter passed is a comma, it will do special handling for CSV files, basically to wrap everything in the quotes. So the delimiter is changing from a pipe delimiter to a quote, comma, quote delimiter. And should any errors occur, we will trap the errors and return false for the function. And if you're running under the console compiler, it would push the error out to the log. So that runs quite successfully for taking a pipe delimited file into an array and outputting it as a CSV file. However, this function handles strictly a one-dimensional file. What happens if we wish to handle a two-dimensional file? Well, since we've created the 1D file.csv, which is comma delimited, we're going to load that in to an array as a two-dimensional file. So we'll create a new function to perform that. So here's our new function, load a 2D file, and it's loading the output from the previous function, the 1D file.csv. So our function load a 2D file takes a single parameter, which is the name and the path of the file to actually load. And we're going to use another of our pre-built functions in our file handling library called read the CSV file into an array. This will take a CSV file and bring it into a two-dimensional array, using the delimiter, which is the comma, to indicate when to switch on to a new cell. So having loaded the two-dimensional file into an array, we'll then want to save the file back to disk. Now, while you wouldn't normally load a 2D file into an array and save it back in exactly the same format, this gives you a mechanism by which you can save any two-dimensional array to a file you can use for something else. So first, we'll populate a file name to which we want to save the file. We'll call this one 2D file CSV. We're going to set it as a comma delimiter, but it could be any other delimiter. It could be a pipe, it could be a tab, it could be any character you wish. And we're going to use another function in our new library called ArraySave2D. This will take three parameters: the name of the file to save to, the pointer to the array holding the data, and the delimiter we want in the file. It, like the other function, will return true or false. True if it works, and false if it does not. If we try running our program now, we should get a new 2D file CSV getting created. And there is our 2D file CSV. If we open that one up, we should see it appears in exactly the same format as the 1D file, which it does. So we have successfully taken a CSV file, loaded it into a two-dimensional array, and then tested our function to save the two-dimensional array to ensure it appears in the correct format. As a test, we can change our delimiter to some other type of character and run our application, and we should see our file now appearing with the tilde delimiter. And there it is. So we now have a mechanism for loading and saving one- and two-dimensional files. The final function we're going to look at today in our new library is a function to copy an array. You may ask what the purpose is in copying an existing array. If you are using the contents of an array as a template, this function will come in very useful. We're going to be handling both one-dimensional and two-dimensional arrays, so we'll create a little function to help us do that for a one-dimensional array first. We will load a text file into the one-dimensional array and save it back out to disk, having cloned it. So we'll call this new function copyAnArray1D. This we're using the 1dfile.txt file. So this function will take a single parameter, which is the name and the path to the file we're going to be loading. We're going to have two arrays, the str data array, which is going to contain the data held within that file, and our str copy array, which is going to be cloned from the first array. Firstly, we're going to determine just the file name, excluding the path. We can do that very easily using the parse command, passing it the parameter of the file name, using the backslash and a -1. The -1 with the parse command means we're starting to count numbers of elements from the right hand side of the string. So this would leave us with just the file name. And we're going to populate the name of the file to save, prefixing it with the words cloned array. And as we've done before, we're reading the file into an array, using an existing function within the file handling routines library. And now we're going to use the new function, which is called clone array. It takes a mere 3 parameters. The first parameter is the source array. The second parameter is the name of the array you wish to copy to, the clone. And it will pass back a true or a false if it's worked or not worked, and if it passes back a false, the str error variable will be populated for the error that's occurred. So the clone array function will return a true or a false. If it's true, then the array has been copied successfully. If it's false, the str error variable will contain the error, and we can put that out to the log as well. Once we have cloned the array, we want to dump the array out to disk to ensure that it has successfully been cloned, so we can then compare it against the original file that went in. So the file feeding into this is the 1dfile.txt, which has a header line and 3 data lines. So if we run our application now, it appears to have copied successfully. So our cloned array 1dfile.txt contains the same information that was in the original file. So we have successfully loaded the file into an array, cloned the array, and saved the array to prove that it's in the same format as the original file. So can we do this with a 2-dimensional file? Well, we will create a new function to perform that, called copyArray 2D, and this will load the 2dfile.csv file. If we have a look at that one, we'll see this is our comma delimited file. Now we'll want to load this one in so that each element of this will go into a separate cell in the array. So this function will be very similar to the previous one. The only difference being we will use a separate function within the file handling routines library called read the CSV file into an array. This will load the CSV file into a 2-dimensional array, which we can then attempt to clone, using exactly the same function, passing it exactly the same parameters, the source array, the cloned array, and the error should one occur. And in order to determine whether the cloning has been successful or not, we'll need to dump that array out to disk, so we can reuse the arraysave2d function. So here is our arraysave2d function. We're passing it 3 parameters, the name of the save file, which we set up here as in cloned array with the original file name, the reference to the array we want to save, in this case the copied array, and the delimiter we want to set up. So in this case we'll set a delimiter as being a comma. And as this function will return true or false, we'll just put in the messages to our log. So if we have a look at the original file is the 2D file CSV, which is a comma delimited file. If we run our application now, the log is telling us that the 2D cloned array has been saved successfully. And there indeed is a file called cloned array 2D file. If we open that one up, we'll see there is our file, if we compare it to the original, and there are the two files. So we have successfully loaded a text file into a two-dimensional array, we have cloned that array, and we have saved it to disk. So you now have the ability to use an array as a template, which once loaded into memory can be cloned as many times as you require and then populated with data. So let's have a look at the code that does the cloning. As you saw from the code we looked at already, there is a single function to clone an array, and it successfully clones both a one-dimensional and a two-dimensional array. So here is the clone array function. This takes in three parameters: the first array that you wish to copy, the second array, which is the destination you wish to copy to, and the str error should an error occur. This is passed back to the calling routine. The key point in here is this command here, the array attribute command. Using the array attribute command, you can determine whether the incoming array, the one you wish to copy from, is either 1, 2 or more dimensional, using this parameter, number 3. This will return the number of dimensions. If that returns 1, it's a one-dimensional array. If it returns 2, it is two-dimensional, and so on. So we have an error trap in here to check to see if the dimensions are more than 2, then report the error and exit. In the error, we're using the very useful function name command. The function name command is an inbuilt process to PowerBasic that will return the name of the function that you are actually executing at that point in time. This is particularly useful when debugging, and can be used in your logs to report where an error has occurred, right down to the name of the function. So if we get past this point in the code, we can then redimension our destination array based on the number of dimensions that we have worked out previously. So we're going to redimension it as a one-dimensional array, being the same lower bounding and upper bounding as the source array, or for a two-dimensional one, we're doing it as a two-dimensional array. And after that, it's a simple matter of populating the new array from the original one, either for one-dimensional or for two-dimensional. Should you find a need to support three-dimensional arrays, this section of the code could be easily extended. And should any error occur, it will be populated into the str error variable, which is passed back to the calling routine. In the next video, we will be covering the comparison of arrays. But that's it for today. Thank you for watching.